These are examples of getting information from the string. So here we create a string, and then we can use length, which returns the length of the string. There is also size, which is the same as length. And there's also check for an empty status of the container. Right, so if we create a string by using default constructor without any initializer, and then of course the string will be empty and its length will be 0. Sometimes you need to be able to convert your string object to a C-style pointer to a string of characters. And in this example, we construct an object named file name. So this is a string. So this is an object, right? So I'll draw it like a box somewhere in memory, and probably uses this C-style string as a prototype of the content to preserve. So somewhere it allocates dynamic memory that contains all of these characters. And here it stores the length, and of course it stores the pointer to these characters in computer memory. So this string, which in itself is something that is stored in read-only memory in the computer, is used as a prototype to copy these characters into this dynamic memory. And then we decide to use this object file name, our string, as the file name in C-style or C library function fopen to open the file for read-only in read-only mode. So the compiler will refuse to do this because the string does not automatically convert itself to this low-level C-style pointer of characters. So what we can do about this is that we can use this C-stir function, which returns back a read-only access to the dynamically allocated characters in computer memory. Okay, so it's possible to do this, but the only restriction is that, of course, through string here we can modify these characters, we can make updates to them, we can append more content, but C-stir returns back a read-only access to the block of dynamically allocated characters. Basically, this member function C-stir returns pointer to this sequence of characters, and it also guarantees that there will be a 0 terminating character at the end of it. Okay, so this is the 0 or null character at the end. So this looks pretty good in terms of null terminated C-style string. However, if you'd like to store it as a pointer to characters which is not constant, that will not compile. It's not going to work. If you'd like to extract a pointer, right, or create a pointer which is pointing to this dynamic memory right here by calling C-stir, okay, so then what you need to do is you have to specify that this is a pointer to a constant character. And also, if you're going to continue using this string and you want to append or use any other function which changes the content of this dynamically allocated memory inside the string, this pointer, we say, is invalidated. You have to basically forget it, and it's good only as long as the string is unmodified. As soon as you start using other functions which can potentially modify the content of the string at runtime, if you store this pointer somewhere, it is going to be invalidated and dangerous to use, because this dynamic memory could be reallocated somewhere else, right here, as a result of this append. And this memory could be already returned back to the operating system. So, of course, this is not So this would be relocated somewhere else physically, and here it's a really dangerous idea to use this pointer which was obtained before this modification to the string. It's just something that you need to know about this function cstir. Search operations, of course, doing search on on the content of the strings is extremely important, and very often that's the reason why you're using strings. So these are possibilities for your searches. So here we have string example, which contains hello world content, and we want to find substrings inside this, and the possibilities are that we may approach it from front or from end. And so here finding something inside the string, like looking for a substring WORL, which can be found right here, will return the position. This will return the position. So we just validate here that the position is equal to 6. If we'd like to find something that cannot be found here, here's an example where we're returning a non-existing position constant, which is defined by the string class, and you can check against this. Okay, so here we're actually expecting this endpose to be returned by attempt to find something that is not contained in our string. Just like looking for substrings, you can look for individual characters, and find has another counterpart, which is rfind, which is reverse find, finding from the back of the container. So this attempt to find finds the character lowercase o looking from front of the string, and rfind will be looking for character o from the back of the string. So this will be finding this character, and so the corresponding positions, if you can't count everything, will be 4 and 7. Now there's also a version of find which is not looking for a specific substring, but essentially here is looking for vowels, and this will here specify that the idea of find first off, the idea of this is that look for characters, for any of these characters, and give me the first one that you find. So A, E, I, O, U. All right, so of course E is the first one that corresponds to this category or group of characters, and therefore its position is 1. So we're asserting here that what we find by this is position 1. So don't mix those up. Find is for specific substrings, and find first off always just looking for one character that matches one of these characters. And likewise, find first not off would be looking for something which is any character that does not match any of these. And of course the first character here does not match any of these, and so therefore the return position will be 0 in this case. So these are basic ideas behind these find, the family of find member functions inside string class.